Welcome to our fifth example of homogeneous. Please make sure you watch all the previous four videos to get four examples of homogeneous. So here the question is x times dy dx equal to y plus square root of x squared minus y squared. And we're interested on this domain x is bigger than 0. Okay, very good. So the first step is to solve for dy dx. So you can divide both sides by x. So I get y over x plus square root of x squared minus y squared over x. Now because of this square root, how can I move this x inside the square root and distribute, right? So think about that. So for example, if I have square root of 5 over, let's say, 7, you can rewrite as square root of 5 over 49, because you can, when I move this 7 inside the square root, I need to do 7 square, right, to make it a 49. So they're equal. So the same trick we can actually do. I can move this x inside square root by making x square. So let's do that actually, because I have to express everything in terms of y over x. So that's the idea, right? So I'm going to move this x inside the square root as x squared, and I'm distributing that under each term. So I move this x inside the square root as x squared, and then I distribute under each one. X squared over x squared minus y squared over x squared. So you can probably see where I am heading. So this will be 1, and this will be y over x squared. So let's write it down. So I get y over x plus square root of 1 minus y over x squared, like that. So everything on the right hand side is in terms of y over x. So now I can do the substitution. So the same substitution every time for the homogeneous. V equal to y over x. First cross multiply. Y equal to Vx. Now you take the derivative. So dy dx using the product rule is dv dx times x plus v times the derivative of x with respect to x, which is 1. So let's do the substitution. So in place of dy dx, I substitute this. And in place of y over x, I substitute v. So let's do that. So I end up with dv dx times x plus v equal to, and in place of y over x, I write v plus square root of 1 minus v square. I cancel out v from both sides. Makes life easy. In general, life is not that easy. But in this particular example, it is easy. So we are very happy on that easy part. So now I get dv over dx times x equal to square root of 1 minus v square. So I can do that flipping business that we are doing on this example. So I have a invisible 1 here. So I can bring it on the right side by flipping over. And same way, x over dx, I can flip and make, and then moving it to the other side, right? So let's do that. So when I flip that, it become 1 over square root of 1 minus v square. And then this dv I copy, equal to, and when I flip x over dx, it become dx over x, which I can write as 1 over x times dx. So that's just dx over x. Taking integral of both sides. Now the integral of the left hand side, something familiar that you probably remember from your calculus 1. So if not, look at a integral table and it will remind you. That is exactly the inverse sine of v. So that's the arc sine or inverse sine. That's exactly the sine inverse of v, equal to the integral of 1 over x is ln of x. Don't forget to write absolute value plus c. But I can drop the absolute value of x because the x is bigger than 0 is part of the question. If you look at the question, it actually tells you that x is bigger than 0. So if I want, I can drop the absolute value. But I'll not do this right now. We're going to do it later. So let's leave the absolute value of x as it is. Let's solve for v. So if I take sine to both sides, so just to make sure everybody understand, I'm taking sine to both sides. So here sine and sine inverse are inverse function, so they cancel each other. I get v equal to sine of ln of x plus c. But don't forget the v is y over x, so we have to put it back at the end. Finally, I can actually make it explicit in this case. So if you multiply both sides by x, so I get an explicit solution. Y equal to x sine ln of absolute value of x plus c. But because x is bigger than 0, if I want, I can drop the absolute value. So that will be y equal to x sine of ln x plus c, since x is bigger than 0 here. So how the graph looks like in GeoGebra? So let's take a look at it. So we're going to go to the GeoGebra, and I actually did this before just to save some time. And my C is my slider, and I enter the function x times sine of ln of x plus c here. And at this moment, my C is 1.1, and that's the graph looks like. Remember, we're only interested is x is bigger than 0, right? And you can do an animation here, right? Look at the beauty. Maybe I can actually show you a big picture here. Look at how the behavior looks like, right? It reminds me of a Chinese dance that they do with a long ribbon, right? Uh, just remind me of that. Okay, what happened if I replace x by the absolute value of x? If I just do the absolute value, let's take a look at it how it looks. So if I just replace this, x by absolute value of x, right? Here on the ln x, let's see. I don't know how it looks like, because for the I have to put the absolute value if my x is general right here. So let's actually do that. Let's see how it goes. Wow, now you have the other side, right? And that makes complete sense. That will be an odd function, right? Because if you replace x by negative x, it doesn't change here, but this will make it a minus outside. So that will be an odd function. So it should be symmetric around the origin. So it makes perfect sense. So let's actually play here a very balanced dance. So it's the dance of the graph. Very satisfactory, actually. I can watch it for a long time, but of course, you don't have to watch it. So I'm going to stop share, and then perhaps I can watch a little bit more. So always remember you can do it. Always believe in yourself. Thank you. Bye bye.